before I start, I'd like to thank Bractlet for sponsoring this tech talk, and let's dive right into it. Today, we're going to explore the wonderful world of message brokers, and especially Kafka. So we'll basically cover some subjects here. We'll start talking about how business and technology evolve together. Then we're going to talk about how systems usually communicate to one another, what exactly is a message broker, when should we use Kafka, and also a brief overview about what Kafka is, and then we're going to wrap up and have some time for questions. So let's get to it. First of all, we need to understand where our applications are born, right? Because business and technology, they evolve together, and basically the consumer and the business needs drive how we build our company products, and at the end, our applications. So for those familiar with the basic idea behind domain-driven design, that's the basic concept of creating applications from a deep understanding of the problems of our domain. We'll dive into it, but basically our domain encompasses everything regarding our market, our processes, ideas, business terminology. So let's say we have an e-commerce that sells clothes. That will be everything that is more important for our business. So because we are an e-commerce, we could say that having the right processes that are fast enough so that we can have a fast customer support, fast shipping, those are domain-related issues that we need to deal as a clothing e-commerce. We also have our subdomains. We can look at them as components of our main domain. So they usually reflect our organizational structure. We could say that a subdomain is the warehouse, the catalog, maybe the engineering team, the customer service team. We have our domain model, which is sort of an abstraction of our domain and all the interfaces, processes, and products that deliver value to our customers. And we also have the bounded context, which are basically all the logical boundaries, inputs, outputs, events, requirements, processes, data models that are relevant to our domain. So in an e-commerce, we could say that mapping out how we acquire customers, how do we acquire new orders, how the data flows within our processes and systems, it's basically what the bounded context will look like. And all of these contexts really dictate what applications should be built and how they should be built. So they really dictate how we as developers are going to do our jobs. And if the business needs and the customer needs and the way the data flows really dictate that, we should then look at how our systems communicating. And basically, we have two big ways of looking at it. The first one is the monolithic applications, which is basically the way we used to build applications so far. That basically means having the whole application with a common database, a common data layer, and they usually communicate through function calls. So if you think about all those subdomains, they'd always share the same database, the same application layer, and usually they'll have different modules. And the good part about that is that it's usually easier and faster if you want to just make small changes. But as your application grows and grows in complexity, whenever you change something in one module, you might break something elsewhere because you have a really tightly coupled application. And with microservices, the whole idea is breaking apart the subdomains in standalone applications. And for that, you need to decouple the communication, but because you can't simply do a function call, because those are separate applications. And then you have events or messages as really like the source of truth of your application. And these subdomains or these microservices will use those events to communicate relevant information with one another. So what is a message broker then? We can look at message brokers basically as a middleman that facilitates communication between different applications and allow them to exchange messages or events. So as a middleman, the main role of message brokers is receiving messages and delivering them to the right recipient. And the main advantages of using message brokers are decoupling the sender and the receiver. So you have different applications. They can be both producers and they can receive at the same time, but they are not tightly coupled. So you can escalate the application separately. And also if you have one application that is down, the events are still in your broker and can still be consumed whenever the application comes back on. You also have queuing, so usually these brokers hold queues and that temporarily store messages until they're consumed. Some of them also have the ability to store those messages for however long you want, just like you do with a regular database. They also do routing, so they can route messages to the appropriate destination based on predefined rules and criteria. And last but not least, message brokers help us with reliability and scalability because they are usually designed to deal with high throughput and high volume of messages. And we have several message brokers out there. The most popular ones are Kafka, which is the one we're going to dive deep today. We also have RabbitMQ and Amazon SQS, just to mention a few. And without further ado, let's talk about Kafka. Not the Czech author, but basically Apache Kafka and Franz Kafka had the same concerns really because Franz Kafka works usually dealt with communication, bureaucracy, and the complexities of modern society. And Apache Kafka was named after him basically because as a broker, it tries to deal with the same types of communication, complexity, and bureaucracies that we live on our organizations. And that's why Apache Kafka has this name. And I'm going to read a quote from the author, which I think you'll guys will relate. If you've ever worked in a huge monolithic code base, it says, and sorry for my English, I'm constantly trying to communicate something incommunicable, to explain something inexplicable, to tell about something I only feel in my bones, and which can only be experienced in those bones. It looks like a deep suffering, right? Of someone who's trying to make sense of the outer and the inner world. And if you are a developer in a large monolithic code base, that's probably how you're going to feel, because you usually won't be able to communicate to outside services. All your data structures and the data structures you think you need will usually not be there in your database. The other modules just don't understand your inner functionality. And every time you try to communicate with the outer world, it seems that you are breaking something. And you know, the good thing about microservices and decoupling these applications is that you can sort of better work through these problems. And a message broker is your best friend to help you go from a monolithic to a microservice infrastructure. So let's talk a little bit about Kafka. This is a definition of Kafka in the website. Apache Kafka is an open source distributed event streaming platform. It's used by thousands of companies for high performing data pipelines, streaming analytics, data integration, and any application that is really critical. It's used by more than 80% of Fortune 100 companies, so it's really trusted by huge players in our industry. Most of manufacturing, banks, and telecoms use it. And we can break down Kafka into four main components. We could start looking at Kafka as really an architect that is behind the scenes, making sure data moves smoothly throughout all the applications that need to touch that data. And it's basically trying to orchestrate that data flow. And if we were to think about this architect as an architect trying to build a chain of supermarkets, then we could look at a cluster as an instance of a supermarket that contains many specialized aisles. And these aisles is what Kafka calls topics. They're basically organizing data that has similar use into specific topics or aisles. All these aisles have different partitions. We could look at them as shelves. They're basically holding data within those topics. And you also have producers and consumers. Producers are applications that are producing events to specific aisles or topics, and consumer is whatever application needs to subscribe to that specific event in order to do whatever that application needs to do. So when should we use Kafka? I brought here the three main applications for Kafka, but there's really several use cases. The first, and maybe what Kafka is most used for, is microservices communication, because Kafka serves as a reliable layer between microservices, and it has a distributed architecture, so it can scale really easily, and it really helps us decouple our application. It helps with async communication because the systems don't have to communicate in a synchronous way. It's also really used for real-time stream processing, so for all the scenarios where you need to process, analyze, categorize, and modify large volumes of data in real time, Kafka is really good. And data integration and ETL, which stands for extract, transform, load pipeline. So Kafka is really good on integrating data from different databases and sources, processing that and outputting that however you want. We can look at Kafka in action. Basically, here we have our Kafka cluster. We can have a bunch of different services that are producing events to the cluster, to specific topics. We can have consumers reading those events however they want. But we can also do our other cool stuff, like we can have connectors that connect to different databases, so we can input data from databases. We can export the data to other systems. And there's a lot of built-in functionality that we won't get into, but they make Kafka really complete application. And if you were to look to Kafka in code, it's really easy to start a cluster. You can go to Confluent's website. They're probably the main service provider and host for Apache Kafka application, even though it's open source, so you can just deploy it yourself. You can go there, set up a cluster, create our topics, and then you can go to your application and create a producer and a consumer. So this is from an actual real application. Here we are creating an instance of a producer. We are assigning that producer to a specific topic. It's going to produce a message, which usually have a schema with all the relevant information that microservice has produced. And the same way you can create a consumer, so another part of the application can subscribe to that topic and consume messages from a topic in a specific partition. And these applications, you know, they can be deployed separately, and they'll just produce and consume whatever events are more relevant to them. Wrapping up, Kafka is great for helping us decouple systems and make sure our applications can communicate between our microservice infrastructure. It helps us build resilient systems because when we have a decoupled application, but our events are in a separate application, no matter what happens, this distributed architecture will make sure we'll always have access to the event, and we'll always be able to continue processing and running our business logic. And scalability, so you can scale your microservices a lot, and Kafka can handle hundreds of topics, thousands of partitions. So huge companies use it. It's highly unlikely that we'll run into scalability issues when we are using Kafka. And if we think about it, our job as developers is really abstracting away from code and understanding that our role is to build the right applications the right way to help customers and business needs. And understanding the role of message brokers, of Kafka, of different types of architecture can help us plan what we're going to build and make sure we build stuff the right way. So this is my works cited, great books on Kafka and event-driven microservice. And I'd like to thank again Bractlet for sponsoring this tech talk, and thank you all for your attention.